We now move on to consider the welfare implications of taxes. In other words, the impact they have on consumer and producer surplus, on tax revenue, as well as deadweight loss. To do this, we'll initially begin by assuming that consumer tastes are quasi-linear. This will again allow us to think of the market demand curve as if it arose from a single representative consumer whose tastes are quasi-linear, and thus we can interpret the market demand curve as a marginal willingness to pay curve and measure consumer surplus along it. We begin with an initial market equilibrium P star and X star prior to the imposition of the tax. We then introduce a tax T that reduces the equilibrium quantity to XT, and we can already get a sense of where the deadweight loss will lie. Initially, the market produced X star, capturing the entire surplus that lies between the demand and supply curves to the left of X star. Now that we're only producing XT, the shaded area will no longer be produced as surplus for anyone. Consumers will end up paying the higher price PD, and producers will receive the lower price PS, with the difference between the two equal to the per unit tax T. The before-tax consumer surplus is the area below the demand curve down to the price P star, in other words, the area A plus B plus C. But after the tax is imposed, consumers pay the price PD, and so the consumer surplus that they are left with is just area A. The before-tax producer surplus is equal to the area above the supply curve up to the price P star, in other words, area D plus E plus F. But after the tax is imposed, producers only get the price PS, and thus are left with producer surplus of just area F. Consumers therefore lose B plus C, and producers lose D plus E. But the government collects tax revenue equal to T times XT, which is equal to the area B plus D. So B plus D, although it's lost by consumers and producers, is recovered by the government as tax revenue, leaving us with the deadweight loss of just the shaded area C plus E. In panel B, we use the same demand and supply curve, but now we introduce a subsidy instead of a tax. A per unit subsidy will increase the quantity the market produces to XS, and we can already see that this will produce a deadweight loss equal to the shaded area. The reason for that is that for quantities between X star and XS, the marginal cost as represented by the supply curve is greater than the marginal benefit as represented by the demand curve. And thus for each unit that's produced between X star and XS, we incur a deadweight loss. Just like with taxes, we can read the producer and consumer prices off of the supply and demand curves at the new equilibrium quantity, which is now XS. But now, since XS occurs to the right of X star, the producer price will be higher and the consumer price will be lower. The difference between the producer's price PS and the consumer price PD is then the per unit subsidy S, which is also the distance that we insert to the right of the original equilibrium between the supply and demand curves to determine the new equilibrium quantity XS. Before the introduction of the subsidy, the equilibrium price was P star and the equilibrium quantity X star. This gives us a before subsidy consumer surplus of area G plus H, the area underneath the demand curve down to the price that consumers pay. And we get a producer surplus before the subsidy of area I plus J, the area above the supply curve, up to the price that producers receive. After the subsidy is introduced, producers get a price of PS, so the area above the supply curve up to the price that producers receive now becomes area H plus I plus J plus K, which is the new producer surplus under the subsidy. Thus, producer surplus increases by H plus K. consumers only have to pay the price PD after the subsidy, and so their surplus increases from the initial G plus H to G plus H plus I plus N plus M, the new area under the demand curve, down to the price that consumers actually have to pay. Thus, consumers become better off by the area I plus M plus N. Together, consumers and producers are therefore better off by the area H plus K plus I plus N plus M. But now we have to consider the cost of the subsidy that the government incurs. The government will have to pay the per unit subsidy S for each of the XS units that are sold. In other words, the vertical distance S times the horizontal distance XS, which is equal to the rectangle H plus K plus L plus I plus N plus M. Thus, the cost of the subsidy exceeds the benefit produced for consumers and producers by the shaded area L.